In today's video, we will continue solving absolute value inequalities. So let's jump into our first problem. Here we have 1/3 times the absolute value of 2x minus 1. Minus 4 is greater than or equal to 2. So before we can split up our inequality, we're going to need to isolate it. In order to do that, our first step would be to add 4 to either side of our inequality. So I'm going to add 4. That leaves us with 1/3 times the absolute value of 2x minus 1 is greater than or equal to 6. And because of the 1/3, we're then going to have to multiply each side by 3. Right? So I will write that in there. Multiplying by 3 gets rid of our fraction, turns that into a 1. So the next line would just be the absolute value of 2x minus 1 is greater than or equal to 6 times 3, which is 18. Okay, so then we're left with the absolute value of 2x minus 1 is greater than or equal to 18. So now we can split into the two possibilities. So since 2x minus 1, the absolute value is greater than 18, I could write it as 2x minus 1 is greater than or equal to 18. That's one possibility, right? The other possibility, or the other case, would be 2x minus 1 is less than or equal to negative 18. Right? Because if 2x minus 1 is, let's say, negative 20, the absolute value would be 20, and that would make our original inequality true. But if 2x minus 1 was like negative 10, then the absolute value would be 10, and that would not make our equation true. So with greater than, remember, it splits, it goes in opposite directions. So then we can solve each of these inequalities. So on the left side over here, I will add 1 to both sides. That leaves me with 2x is greater than or equal to 19. Right? And then I can divide either side by 2. And that leaves me with, on this side, x is greater than or equal to 19 over 2. So that's one possibility. The other possibility is over here on the right. So same thing, I'll add 1 to either side. That leaves me with 2x is less than or equal to negative 17. And then again, I can divide by 2. And that leaves me with x is less than or equal to negative 17 over 2. Okay, so we found that x is greater than or equal to 19 over 2 and less than or equal to negative 17 over 2. So before I continue, I want to make sure that we have this in its decimal form, right? So 19 over 2 that is 9.5, and negative 17 over 2 is negative 8.5. So we can graph our answer on a number line and see what it looks like in that way. So we have x is greater than or equal to 9.5, right? So let's say that's right about here, close to 10. So I know it goes from 9.5, which I will write down here to indicate, and it goes all the way over, right? It's greater than or equal to, it can keep going. In the other direction, x is less than or equal to negative 8.5, which is over here. Let's say right about there-ish. We'll say negative 8.5, right? And in the opposite direction, it'll keep going. So there is our solution on a number line. And finally, we want to write our answer in interval notation. Right. So since there's this jump, so now I want to write my answer in interval notation, right, using our brackets and parentheses to indicate the solutions of x. So on one end, I know that x goes down to negative infinity, right, on this left side of my number line. So I know it goes down to negative infinity, and it comes up to negative 8.5. I'll put a bracket around that because it exists at negative 8.5, right? It can be equal to negative 8.5 or less than. And then to indicate our jump, right? I'll call this our jump. Where x doesn't exist, that solution doesn't exist, I'm going to use a u. And then, to indicate the other side of my solution, well, x can be greater than or equal to 9.5. So I'll put a bracket around 9.5 and put it up to positive infinity, which gives me a parentheses. So that would be our total solution, right? Okay, let's continue with another absolute value inequality. So now we have 4 times the absolute value of 5x plus 1 plus 2 is strictly less than 26. So again, the first things that we need to do is isolate our absolute value. That way we can consider the 2 possibilities. So first what I'll do is I will subtract 2 from either side. And what that leaves me with is 4 times the absolute value of 5x plus 1 is strictly less than 24. And then since I have a 4 being multiplied, I will divide either side of my inequality by 4. And what that leaves me with is the absolute value of 5x plus 1 is strictly less than 6. Okay. So now we've reached an important point, right? We just have our absolute value strictly less than 6, so I can consider the 2 possibilities. Right, I can split up this inequality to find my solution. So one possibility is that 5x plus 1 is strictly less than 6. That's possible. The other possibility is that 5x plus 1 is strictly greater than negative 6. Oops, I know what I just did. The other possibility is that 5x plus 1 is strictly greater than negative 6. So really what this looks like when we put them together in comparison to when it was greater than is that 5x plus 1 is less than positive 6, and greater than -6, right? For less than, it does fall between. So since I've written my inequality like this, I can now solve both sides of my inequality at the same time. So what I can do is I can subtract 1 from either side, and that leaves me with -7 is less than 5x, which is strictly less than 5. And then I can divide either side, or rather all 3 parts, by 5 to isolate my x. And what that leaves me with is -7/5, which we can rewrite as a decimal. And that becomes -1.4. X is in the middle, and 1. So we know that x is between -1.4 and +1. So what that looks like on a number line is I'll have an open circle on 1, right? Since it's not equal to 1, but it goes up to 1. And I will mark -1.4 and also put an open circle around it. So x is in here, right in the middle. It's between -1.4 and +1, but it does not equal either of those endpoints. So to write this as an interval, in interval notation, I would say that x is between -1.4, right? And there's a parenthesis on it because x is not equal to 1.4, and 1 is on the other end. So that would be your final answer. So for these problems, right, there's no new information. We're still doing inequalities. There are just more steps here. So just make sure that you're doing all your algebra steps and you will be successful.